This is a little bit more of a baseline. I guess yesterday I was starting from Reverie, but now I'm going to start with something which is a little bit more empty. I've tried to empty it as best I could. And then this one is going to be, let's say, Triad V2, let's call it. And then I'll start to lift in stuff here from what I did yesterday. See if that works well. Still with the risk of blowing another 45 minutes maybe. Okay, so I did this globals thing here. I will keep that, and also the die. I should be able to copy in without problems, at least initially. So I'll put that here at the very top, I guess. No, I'll put it right above the challenge, because I have stuff here. So here we have some constants that might be useful, and then I copied in my stuff. And now I'm gonna try to guard that whenever I press save, I can still see this canvas then being populated with something like this, HPG base. And since this is Triad, we're gonna change the name from HPG base to Triad. Alright. What else do I want to copy? In the challenge we have these things I was using, so I'll copy them over. What else is here? Are some game variables. Setup start position I created, yeah. Let's see. Might start to get errors. Yeah, I was thinking so. Setup start position. Yeah, I need to copy that over as well. Is one thing. Let's do that. Okay, now it's happy so far. Now let's do the stuff we're doing in step. I'm not really doing much yet. Set up a canvas. Okay, so here we have stuff that we want to do. Guess here, put our stuff. That's nice. Now we're getting somewhere. So now we need to kind of shrink this down a bit so we don't cover the player thingies. So I'll start, yeah. Should we start with that? Have I copied most of the relevant stuff over? Okay, the configurations can be like this as well. And I should set some basic, almost the same. Show canvas true. Maybe I should keep that. I just added Triad as a name. Okay. Great. Anything else? Graphics, we have 16 by 9. That's what we did yesterday as well. Okay. So now let's get going. So let's move the board over a bit. Set up canvas. I wonder what these are. Area width, area height. That's a bit nice to know actually. Now I have several ways to print things out, but I'll just do what I remember by heart. Self context console log. Context, okay, I was misspelling stuff. Context.console it should be. Don't I get printouts when I am not running? I'm not sure. 8 by 8. Okay. So the way this should work is so I have some shorthand conversion functions. Yeah, so I should work in an 8 by 8 area, and then I should call these functions to convert from 8 by 8 to the area that I have here. So that will require some work. So basically, as I should also be a little bit, I'll call it fx and fy now, because I think I'm using f and y, x and y down here. So let's call it functions x, function y, to get the conversion to where I should be in this area, as that might potentially change with later versions of our page. That's why I'm doing conversion thingies. So here we should generally do things like fx of x and fx of y. So what am I changing now? All those inner rectangles, okay. So let's see what happens. Does something move now? Yes, it does. Now the problem is that I am not I've not considered myself to be within an 8 by 8 area. So that's why I'm going to be off here. So now I'm not. I shouldn't use canvas width and height here. I should use like area height, for example, instead of canvas height, because now I'm not within the whole canvas. I'm working within an 8 by 8 area here. So I'll replace these board heights and board width. Okay, let's see what we end up with. It's still pretty far down here, which is interesting. I wasn't expecting that big of a change. Why do I get that? So I have a board left margin, top margin, outer margin, height, because these are pretty small values, so they should not disturb too much. Board top margin, board outer margin. But now I'm using area width and area height. Get square mid-x. Okay, so this is probably the problem. Yeah. Because this one is using get xy. Board left margin plus board outer margin. No, it's just using, it's not using the canvas in any place. So why does it go all the way over here? I would have hoped by these changes I did now. I don't see why. I don't see any, because it's kind of centered around y equals 9 or something. So why is it positioned that far into the canvas? Okay, so how do I check this? Maybe I can check can check what those converters actually do. So there should be something called X. Okay, there it was. Yeah, GAY min. Maybe I should print those so I understand a little bit more. Because if those are too big, that's going to be a problem. So let's check those. Let's check X min and Y min. This is why, again, losing time from using some library, because it's so much about investigating what the heck it's doing. No, it's 4 0, so it should be fine. Okay. So it's 4 in, that's to skip those labels there with the player names, and 0 is at the very top, so I should be placed somewhere there. That is funny. Why doesn't that happen? Height should still pretty good. Okay, but let's continue then to do this. I'm not so sure why I have this problem. Do I always put the function right in here, maybe? Feels like one good way to do it. I'm doing fx or y. That's not so nice. The problem with copying. So maybe that was the biggest problem. Copying stuff. Yeah, that was the biggest problem. So the board is a little bit big now. Okay, but let's continue to do this. These things. Wherever I'm placing something, I'll use these functions. But here it's a little bit different. Still, I'm not placing the dice according to this. Because they have their own canvas thing. So they need to also have access to these functions because I'm drawing on the canvas directly here. So I guess what I'll do is I'll make HPG class, HPG instance also global. And then as soon as I've created it here, I will do globals.hpg is equal to this one, which means that I can use those functions which were called what? These functions were called like so. Just x and dot y. So now going back to the die class. The die class. Now finding stuff is more tricky. It's a bigger file now. So fx, we'll call it the same thing, is equal to globals.hpg.x and y, and then we'll use fx and fy. fy I moved some of the stuff. Here it should just be x and y. What did I miss? Here. Okay, so now we have moved almost everything. Everything is kind of moved, but funnily the outer board is not really adapting. It has the wrong size. That's funny. Okay, we'll see how we handle that. Now let's go to where we draw this thing, the whole board. We need to make it smaller, is one thing. We should probably not adapt it via the width height now, but the width will be... Yeah, we need to fit some more things in there. Actually, one thing that we don't need to do anymore is the moves is part of HPG. So we can remove that thing. Area to the right for recording the moves. That goes away. So now that should disappear. But we still need to move things. We need to make the board a little bit smaller, I think. Not that much smaller, but we need to fit these areas for the dice. Maybe we should shrink them also. That makes sense now. Removed from the board. Okay. So we'll do... What is the other one called? Square inner side. Removed dice side is equal to 0.6 times this one, maybe. Maybe if I'm gonna draw dice there as well. Do I need to maybe need to save that size? Let's guess that for now. So now they're smaller. Now they can go more to the left. That we have in this one, I think. Where to place them. Here we have something like 7. Let's use maybe 6. Maybe 6.6. Okay, now they're smaller. They could also be a little bit more together, so it's clear that those 3 at the top goes for the blue player, and those 3 at the bottom are for the red player. So how do we do that? They start by making them closer together. How much should I define different variables here, or should I just fix it inside the function? So we'll do something. If vertical x, if index, so the first 3 goes on top, then the other 3 here. If index is larger than, so what do we have? 36, 37, 38. Vertical margin is something. I'm using exact values here. Might not be. If I change the size, I should relate things to something like square side here maybe. Let's try that at least. Yeah, so something like that, at least. Might not be perfect. At least they are smaller now. Is everything related to square side? I think so. I guess that looks okay for now. Let's continue with other stuff. So it's a little bit big now, the board. Maybe I'll just make it smaller. Oh, this is wrong setup canvas. Board height. Okay, so we'll just increase the margin then maybe. This one can be small. And the other one can be bigger. Okay, so that affects this one. Aha, because now it's not square anymore. Doesn't make any sense. Why did it move to the right? Ah, the left, because the left margin. Okay, so I actually want this one to be really small, maybe even 0. And the top margin should be bigger. But what happens when I do that? Then the board is not square anymore. This outer one is not square anymore. Okay, that doesn't make any sense. Board height is this one. Okay. Board width is always board height. Okay, so now that one is square, but these ones don't follow. Area width -2. No, it should be. Shouldn't it be board width -2? That looks much more like what I wanted. So now what do we do? That looks like a nice triad board. I don't have it right next to me right now, but I think it looks good. So now it's maybe a little bit too small. Should I relate everything to area height? Why not? So now it goes outside there. That's not so good. So now the top margin is too small. Although it looks like it could go to the left. I wonder why. I'm not sure why I know it was 4 that was being added at the left. That looks a little bit. Why is this one 4? Should I just accept that? Because I have that in all the others. So it's 4 out of 16, meaning it's 4. Yeah, I mean, I guess the board doesn't need to be super big, actually. Okay, so I'll just accept it. Then I need to have a little bit higher margin here. Okay, maybe that's okay. Yeah, so that looks like a triad board. Nice enough, and it's in this whole thing with the HPG, meaning we should get something for free, like the player names should pop up here once we have it for real, live, and people are playing with their AIs. Alright. So that's nice. I guess we're happy. Let's do an export of where we are. Okay, so maybe we should fix the errors when I press run code here. What was that? Pause this move. Okay. Some remainder. We don't have pauses in this game at all, so we remove that. If I press this one, 11:31, we'll just remove that idea. But Maybe remember that resign execute is something that's on the table to use at some point. Oh, I should press here. Float division by 0. Width of text is 0. Why is that? Okay. Something that doesn't fit. Okay, because probably I'm setting the move to be I think I set the move text to be move is none. Where do we have the move text? But why not move? Something else is set info prompt. Result string. Where do I call that? Move string long. Set info prompt. Get text size within. I guess is this one somehow making it to be a 0? I'm not sure why that is. So now I'm debugging something entirely different than what I'm working on. Width of text becomes 0. Okay, so I can guard this one and say that width of text should never be able to be 0. I'm not sure why this is. Maybe I should put something here, like added, triad added, triad modified. Just so I remember, because now I'm changing in this HPG thing I'm using, Human Playable Games. Just trying to guard versus the division by 0 now, so I can get on with things. Okay, so that seems to actually do something. Game end. It's probably some kind of text that I'm generating that is, I don't know. Yeah, game end. Yeah, because I set finish to true. Okay, but now we're getting somewhere. So now we can also press run code. That's always something. What do? We create a little to-do list here. What's the next step we want to do? Maybe we try implement some kind of execute move, so we can actually get moves done. Maybe we also, I think at some point we want to implement something like valid moves probably is nice. Maybe we don't need to generate all valid moves, but at least we need to check if the player's move is valid. So yeah, you can also say that what we probably want to do is that if you want to click like this die here, the 3, we want to show that, okay, you can change it to 2 and go 2 steps up or 1 step up. Going back to what I was explaining the rules here. So the valid moves here would be these arrows that I drew here, the red ones. So that is something to implement, what moves are actually valid to make. What else do we need to do? Okay, we should also do the API thing. Add make move API. I did do that yesterday, so probably copy it over. And then implement step, so you can actually play the game. Implement update canvas, so you can see when a move has been made. Score the players eventually. So then we need to check for end game condition. Yeah, we need to do something so that execute move. I mean, part of that will be implement triads and moving dice to the right area. So when you have a triad, how do we kind of show it? How do you move it so it ends up as a point down here? Yeah. And at the end, implement interact, so we can play the game as humans. Yeah, things like that. Implement execute move. Okay, so actually make move API probably goes over that. We copy over what we had yesterday. We had an API make move, which was the board is a list of ints and is player 1. Okay, so that's a bool, and then you return a list of ints for the move. Okay, make move board and is player 1. I already have something here. Okay, is player 1 maybe instead. Board is a list of ints, and return type is, I think, a list of ints for this game. Now this will not make a lot of sense. Return play move is some of this will actually still be valid. Okay, so as a list of integers representing here I need to add stuff. What we want the move to be. I think it'd be something like index from to index to. You move from somewhere to somewhere. I think that's it. And then we have the index is the 64 long. It's not 64 in this game, it's 36 long. List I like more, covering the board. Index 0, and now we said that to print it more easily, we have the indexes at the start at the top left, and of course I'm not showing the actual. So we should start at the top left of the board. Doesn't have a particular name. Index 1 is the next square to the right. Index 2 another square to the right. On the next row down, index 0, 1, 2, 3, 4, 5, index 6 is the first square of the second row. Index 7 is the second square. Second row, and so forth, row by row up to index 35. I don't really have these names of squares like in chess, or I'm not showing the names also on the board, so up to index 35 in the bottom right corner. And then I should also say also see the description for a visual reference. Please see the description for visual reference. The input parameter is player 1, I guess it was. The red stones, I guess. The red dice. Player 1, and false for blue. I don't know if we're going to keep those colors, but then we have to change this again. The parameter board gives the current board state as a 36 long list of integers. The indexing is described earlier in this comment. Yes, the integer values of the list are 0 is empty, 1 equals die. But now it's not 1 anymore. It's the dice can be 1 to 3. So 1 to 3 is die of player 1. And what did you say? 11 to 13 is a die of player 2. The value increased by 10. So a die with 3 on it becomes 13. Okay, that's a pretty reasonable description so far. Let's try that. I think it's really useful to have an idea of how the move is going to be made. That kind of leads into implementing step. Add make move API, we did that. Implement execute move. Okay, maybe we'll just start with step a little bit. Because now we know how to call the player. Yeah. So step. Somewhere around here, these parts. So we have some kind of boilerplate code from Reversi or HPG, Human Playable Games. And here we are. It's already kind of covering a bit of this when you can play either versus an AI. You can play AI versus AI or human versus AI are the two things we want to cover. So if it's AI play, I mean, we'll focus on that now. That's the aim of this, is to finish some kind of challenge where you can play AI versus AI. And here we should actually use the living solutions instead. But okay, so it's a two-player game. It's not that much of a deal, maybe. Yeah, we'll come back to it. I have it in the to-do list that we should handle if a player dies. For example, the solution times out. But okay, so the normal case is okay. The normal case is that we do self dot context solutions current player x make move. Current player x is equal to 0. If it's equal to 0, then it's true. Then you are play 1. Is play 1 is what we're sending, so that seems to be correct. And then we have self.board with an underscore, so protected. Is that how we set it up? We didn't use the underscore. Do want to be all fancy and do that. Okay, let's try it. Okay, so we're not doing anything yet. We do set up the start position. Don't we do something with the board then? Because we only add to player dice. But we never update the board. Okay, we should do that as well. So, or should we do that? We already have these for loops. Player X or die. Okay. We do the sorting and then we do these things here. Maybe we do it here instead. Self dot board. Okay, so what index do we have? Square X. And what is it equal to? Do we do just to give it a name and to formalize it? Def get what am I thinking? Yeah, get the die number. So I was thinking about this thing where we use die numbers 1 to 3 for player 1, numbers 11 to 13 for player 2. So just to make that a little bit more clear, maybe self comma player x comma die number, die value. So for the first player, we just return that, and else we do, well, we don't actually need to have an else. Oh, but why not? Else return 10 plus the die value. Okay, so then we do get die number. From player X and the value of the die value. Am I using the right index in player X? Is the right one. Die X is the same one, yeah. Maybe something like that, and maybe now we do another debugging here just to see the board. So now we have, okay, so at the top here we have the player 2, 13, 13, 12, 12, 11, 11, a lot of zeros, and then we come back to the end, 1, 1, 2, 3, 3, 3. Okay, that seems to make sense. Okay, back to step. Make move, and we're sending the board in. We have the board now named in the same way. Okay, so what is the move string? Maybe we'll just put from to. Maybe for now we'll just do a string of the move. So it's a short list. To do improve string. If false, self.resign execute. Yeah, we're not using this yet. There's a to do, another to do. To see when we should, if it's not a valid move, resign if not valid move. Execute move. Okay, so this should increment self.x move. Okay. Set player on turn. We change the player on turn. Update the canvas. All right. We have something there. So should we now try to... So I return an empty list. That's not so much to do. Maybe we should implement getting the valid move from the board, because then I can use that in solution class here to actually have them play versus each other. Maybe randomly for now, but at least try to API.get possible moves. Okay. So here we have a convenience function where we allow the player to ask for the possible moves. Maybe that's pretty nice actually. Then you can play randomly like this. So maybe we should keep that. Maybe change it though. Turn list of integers, a list of integers representing the indexes in the range 0 to 35 of the possible moves given. A list of integers which pair, because we're not gonna, we need 2 integers in this game to say what the valid move is, which pairwise give the indexes in the range 0 to 35 of the possible moves given the current board state. The format is index from 1, comma index to 1, comma index from 2, comma index to 2, comma dot dot dot. For the first possible moves 1 and 2. I don't know if that's super clear, but I think here I'm saying pairwise. Here I'm saying that the list is from 2, from 2. I think it's okay. Okay, so is that present here? Get possible moves. Probably I had removed that already. Yeah. So then that's new. So I think we'll do something like this. Possible moves is equal to self get possible moves. API get possible moves. Self get possible moves. And then we do here change from list of tuples, maybe even a set of tuples, to list of ints where the moves are given pairwise. Maybe I'll just copy what I just wrote there. But I had that also. It's already, of course, it's already here. Okay. So that we should do. That's a to do. And then we do return possible moves. So this is turned into a list, and then we return that. But that is still to do, okay? So we said we should implement get possible moves. Okay. So then we'll work from board, I guess. Or we can use the fact that we have self dot the dice. Then we don't have to look through all these ones. What do we actually call them? Self dot initial. Don't remember the names now. Set up start position. So here we have player dice. Okay, we have self dot player dice, which works something like this. Square x value and something else. The graphical component. So we have that, and then we have self.board, which is just the list, which is 35 long. Okay. Probably shouldn't have these named. The exactly the same. Get possible moves set. Maybe is what makes this one unique. So we return a set of tuples with all possible moves. The tuples are index from, comma, index to. Okay. Maybe as a convenience we should also say what so obviously the distance between those two will be the die number that you change to, the die value. But it could be nice as a convenience to have that also in the tuple, possibly. Index from, index to, new value, new die value. So it's a 3 tuple then. Alright, how do we start this thing? We had directions before. Do we have them here in the main class? Or did I maybe not keep them? No, I don't think I did. But we can just put them here. Directions is so x and y value 0, 1. We have 1, 1. So these are like the unit steps that one can take in x and y direction. And just the way I was thinking about now, it should be 1, 0, 1, 1, 0, 1, and minus 1, 1. So then we have it's 1, 2, 3, 4, and then you mirror them 5, 6, 7, 8. 1, 0, 1, 1, 0, 1, minus 1, 1. Yeah, so there are 8 directions, and these 4 with their mirror versions should be it. Those are useful, I think, to get the sets. And then we just go through all the possible dice. Okay, for player X in range 2. No, we're gonna of course want to have a certain player's possible moves. Okay, player X comes in here. Just fixing the graphics there. Alright. So that comes in, so we don't have to iterate over that. But then we had something like player dice, player X dice. Okay, so for die X in player dice, player X. So these are the different dice that this person has. Square X, okay. Maybe we'll put that out here. Square X is then this thing. So from that square then we're gonna check these directions if you can move, or I guess we start off with values is maybe it's a list or a set. Yeah, we don't have to optimize this. Okay, so 1, 2, and 3, and then we should do del the one we have already, because that's not a valid move. I think it was just called value. 5 out of 5, yeah. So I guess we'll just, I think I remember that that's how you do it. L is equal to 1, 2, 3, and I guess then you del on the index. Not like I did. So if you do index 1, you will have removed index 1. Yeah. So what's the other way to do it? Is if we do this and we do L dot remove, maybe. That's more what we want. It's such a short list, so I'm not going to be trying to optimize this by using a set or something. So we do instead values blah blah blah. Values dot remove the one we have already. Okay, so then we have two values to go through. Okay, so we are, for example, this die here, if it's the first player, and then we want to try 2 and 1. So let's say we're trying 1, then we want to try it in all different directions. Now, probably need some more helper functions here to make this our life as easy as possible. We can do something like valid xy. Guess this can be a static method. How do you write that now again? Static method. Return 0 is less than or equal to x less than or equal to 5, and the same thing for y. Do we need to do something similar? Because now we have an index. Didn't we do that, by the way? Didn't we do that? To get x, y, and stuff like that. I have this memory of doing something like that. It's in the globals. Yeah, we have get index and get xy in globals already for this one. Okay. How nice. Do I need to put this one in globals? Maybe not. I'll try. I might keep it here. So we have a certain direction. So we want to take a step in a certain direction. And where are we? I mean, we are on square x, so let's calculate x and y from that. X comma y equals globals dot get xy of the index. That's where we are. And then we go through the directions, I guess. then we need to do it mirrored multiplier. Then we do new x and y, so x2 maybe, x2 is equal to the original x plus d, should we do dx comma dy? Because they are tuples, so x plus multiplier times dx. So then we're taking a certain step, and y2 is y plus multiplier times dy. Then we have all 8 steps, and then we can check if self.valid xy x2 comma y2. Then we can continue. So we haven't gone outside of the board at least. But now we need to check if it's one step, then it's just that board. Yeah, we should check. We should check up to 3 squares. They have to all be empty in that direction. Do we do a little help function for that? Squares to check is equal to get squares in line. And then I guess we get from where we are and maybe dx dy, and then the value, how many steps are we going to take. Then we get the steps that we want to check. Yeah, why not? Squares is empty, and then we do for x in range new value. So if it's a 1, then we only get a 0 here, okay? That's the index. Squares dot append tuples, maybe x plus dx comma y plus dy. Then we take one step, and if it's a 0 we only take, if it's a 1 there we only get one index, then we get one step. If it's a 2 we get 2, and otherwise 3. That should make sense. So then we get the squares in line for should we get x and y, or just no? What do we have? We have get xy. We also have get index from x and y, I guess. Yeah. For x new, x step, x, I don't know. For xs comma ys in squares to check. Then we do if for, so I guess we're in this for loop now. So I guess we do continue. So if self dot board of we need to do the index. I like to write things out. Let's do it. Index is equal to maybe square index to be clear is equal to self dot no. That one is in globals dot get index. Get index of these two. And if that one is not square empty, something with empty in it, don't we have that? The should be 0. What do we call these guys? Die 0. Where are those? Okay, we didn't have. We lost them along the way. Okay, so let's add them. So I did put some globals in here. Yeah, maybe it's a little bit confusing now with different types of globals. Die. But that's the thing. It's 0. Okay, empty square is anyway 0. It's not just okay. Every player can be up to 3 different values, 1 to 3 and 11 to 13. Okay, if it's not empty, then we continue. So then we go through all those, and if we find any problem, okay, then we just continue from that for loop. Okay, that's not what we want. We will set something. So here we are doing a check. Can we go 3 steps in this direction? Then we say move OK is true. Then we say here instead move OK is false, and then we can do continue, of course, but then we have to do once we checked all these ones, we have to do if not move OK, then we need to do continue from this for loop. And otherwise, if we have an OK move here, then we should add it to possible moves. Dot add, and then what do we add? We said it was index from index to new die. Index from is square x. Index to we don't have yet, and then we have the new value is new value. So now we need to calculate square x2 square 2x is equal to, I mean, we know where we end up. We end up in no, x plus multiply times dx. Okay, so here we're just taking one step in that direction. We need to also, we need to take the full step here. So multiply times dx, that's fine, but we also need to multiply with, because it's only one step, yeah. So we need to multiply with new value here. To say that here we've taken the full step, then we check if that's still inside the board. Then we check from x and y. Dx dy should now be, yeah, was just one step. That's good. Because we multiplied there, that's fine. Okay, and then we come to this. Then we know that square 2x is globals dot get index of the square we went to, which is x2 y2. So then we have the 2 index and the new value. Okay, and then at the end, oops. At the end here we return possible moves. Okay, let's do a debug here. Yeah, we call it get possible moves of the player index. We can do that after we have set up the initial position. How exciting. This is the most exciting you get in programming. It's too much just scrolling here. So here, after we do set up start position, I guess we can do self dot context dot console dot log. Probably have some logger up there if I check in HPG. Get possible move set is not defined. Self dot none type. Okay. 1410 squares to check is none. Get squares in line. I never return. List index out of range 1413. Board doesn't have that square index. Okay. Get squares in line. So we know this is a valid xy. Here we've taken the full step. That means we should never go outside of the board here. Okay, now I see one problem. We send in dx and dy, but the x and dy is actually we take the multiplier here outside. So actually the actual dx is multiply times the x. That's the problem. Okay, so it's not super elegant, but I don't like it super much, but I'll do it this way. Because I would like to call it dx if it's actually the difference in x. Okay, so what do we have? We're getting 1, 2, 3, 4 valid moves. 1, 2, 3, 4. Okay. And it says that from 30, where we have a 1, we can go to 25. Okay, now we actually need all these. Okay, so maybe I should just enter them. Okay, so it's saying we can go from 30 to 25 by changing to 1. Well, that's not allowed because 1 is what we already are. So that was not a valid move. That's a 1, you have to change it to something else. And then we can go from 30 to 15, 3 steps by changing to a 3. That's actually a valid move. Nice. Then we can go from 30 to 24 by changing to 1. It's just like it thinks this is a 2, but it's a 1. Okay, so it changes the first die to 1 and 3, 1 and 3. Goes to 30 to 24, yeah, and 30 to 12 using a 3. That is okay, but it's kind of removing the wrong value because it's, and then we're only looking at one die here. So we kind of stop after one die, it seems like, which is a little bit disappointing. And we're removing the wrong value, but that's fun. Then we have stuff to fix. So why are we removing the wrong one if you start in that end? Where do we do that? Remove. We do not remove. Remove the value. Huh. Does it always do this exact thing? If I do it again, it changes the first one to 1 and 3, 1 and 3. Yeah. So we are doing player x, die x, value, and square. Why does it do that? I did try that one. And it seems to, if you remove 2, it removes 2. What if we print this before, when we do this debug here, we print both self dot, what was it called? Player dice. Let's see what's in there, and then we can also do the board. To actually print the board, we should do a super small help function, but no, I don't. So it says that in square 30, it has a value of 1, but then it still keeps the 1 and removes the 2. What else do we have? In square x30, we only have that one. That's funny. What the heck? Okay, so let's attack something else. Why do we only do the first die? For die x in rangeland self player dice player x. So it's a little dictionary here. 1, 2, 3, 4, 5, 6, and then that list is done. Maybe I never. Yeah, I do. Square x is equal to that. And I do. So I pick out the square x there. And here I use remove of the value. But is it one of the continuous that's wrong? Move OK, but move OK gets set here. True. So I do move OK is false. Here, continue. That should continue from this one. So we don't check any more squares once we have a non-empty square. If not, move OK. So we set it to false. Then we continue from that one, which is what we want. And if we have an OK move, we calculate square 2x. That seems correct. And we add the possible moves. That works, I guess. And then it should continue with the next die. I was hoping for maybe one tricky thing to solve, but I don't see the error in either of those. What am I missing? So we have this set. That should not be a problem. Square x, square 2x. Multiply times. If valid x, y. Why does it just do one die? So I guess while I'm thinking about it, I'll do this convenience function to print the board. Because it should be super easy the way we have it set up now. Def maybe we should make so we can print other ones as well. So if board is none, then board is equal to self.board. For x in range 6, print, we can print self.context.console.log. I guess we still print it as a list, I guess. Okay, so what portion of board do we want? We want board x times 6 colon x times 6 plus 6. X times 7, is it? No, x times 6 plus 6. Okay, let's try that. Maybe not print board because we're not printing log board. Okay, where did I put it? This is in it. Where do I do setup? Here. Self.logboard. 1, 2, 3, 4, 5, 6. Yeah, but it needs to always be 2 wide. Is it like that? Um, That's a pretty okay way to see the board, I think. But it doesn't help us now because we still have the same problems. So we're seeing the same thing here. So here, that's figures. But okay, we only get one move from this one here. For die X in range length self-play dice, player X. But no, that one is 6 long. So we go to player X, then we are on the first list. That is 6 long. Why the heck does it not add more stuff? Why does it remove the wrong value? What if I just always say values.remove 1, because I happen to know that the only one it's trying is a 1. Will I get something different? Then it's changing to 3 and 2. And it goes to 15 and 20 and 18 and 20 and 12. Okay. That's nice. So now it doesn't. So this does not. I'm doing something strange there. Values of this one. Why do I. What's that shit? Why did I write that? That's really strange. Okay, so now it's changing to a 3 and a 2. That's at least something. 2 and a 3. And it goes to the same good squares. Okay. One puzzle solved. Obviously some kind of really strange thing I was doing. Then the question is, why doesn't it just continue with the next die and add more? Okay, so if I simply change this to be for die X in range 6 for now, you will have lower number of dice later in the game. So that doesn't help. Is it one of these continues that goes haywire? But it should not continue all the way from there. That's not possible, is it? I only have continue. Move OK. The thing is, if I never reset move OK. So I continue, but then I always start this one with true. What happens if I don't do this one? then I get something more. 2, 2. Then it goes to 20. And 18. Okay. Then it goes to 33 and 12. So that's not 33 is not possible. That's going through its own dice. Then it goes to 15 with a 3. And then it goes to 32 with a 2. That's also not possible, going through the own dice. So at least we can say that this one does something good. Why doesn't it go to the... None of the other dice finds anything. Return is... Oh shit. That's a too long function. Oh my god, what stupid thing. Okay, so now we change things back here. I was one notch in there because it's a little bit small screen also, actually. So I was looking at this for loop when I was putting that one there, but I should have seen that it's one more there. Okay, so now we have good reason to believe that this actually works. Let's try some of the last ones here. Let's see, 33. That's that 2 there. It goes to 15. That is 3 steps up. That's good. It changes to a 3. Next move, 34. That's that 2 there. It changes to a 1 and goes to 27. That's good. 31. That is that 1 there. It changes to go to 19. That's also good. So only good moves. So how many moves are there? This one has, so it's, most of them, this one has 4 moves plus 4 moves plus, so it's 8 plus 5, 13. This one has 13, 16 with 1s, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. If I'm counting correctly, it's 27. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. I'm pretty happy that that's okay. Okay, so now we have that. Now, yeah, now does this convenience function get possible moves set? Get possible moves. Now we're not gonna give, yeah. So we change from set of tuples, okay. Possible moves list is an empty list. And then we go through all those tuples. X from, comma, x2, comma, don't use in possible moves list. So it's going to be not be sorted now, but who cares really? We don't promise that. Possible moves list. Oops. We add this little list. And now we return it. Okay. So then in the solution, when we call the solution here, we can do print self API get possible moves. I guess we never call it now, maybe in step. We do call it. Alright, so why don't we get a printout? At least we try to call it, okay. But why don't we see this one? Step, X, move and all that. Ah, because it's using hpg.log, which probably does something semi-clever. So debug is not set maybe.